Welcome back. Today we will be talking about Unit 3.3 Polynomial Division, and we will be talking about the long division, synthetic division, and remainder and factor theorem. So long division, it is just like a long division that you are used to doing it ever since in elementary school. What we need to change is we consider degree of x like the place value. For example, if it is x4, then 4 is the place value, right? And this is how it will go. I will explain you with one example. For instance, we have one rational expression, and not all the rational expressions would be easier to solve with the long division. For instance, in this one, if you look at the rational expression, the highest power in the denominator is greater than the highest power in the numerator, right? So divisor's highest power is greater than the numerator. So in this case, we cannot reduce it further. So this is not what we are looking for. On the other hand, if we have something like the highest power in the numerator and the highest power of the denominator, if we compare, then the numerator's power is greater than the denominator's power. In that scenario, we will be able to reduce it further. For example, in this case, the highest power in the numerator is 4, but the highest power in the denominator is 2. So we can reduce this rational expression. Let's try to reduce this rational expression with the long division. So what we have to do in the long division, the numerator part will go inside the house and the denominator will stay outside the house. So whenever I teach the elementary students, I say something called dead mice smell bad. So divide, multiply, subtract, and bring it down. So in this case, what we have to do, we need to find a way to get rid of 3x to the power of 4. And we can do by multiplying the denominator by 3x squared. Because 3x squared times x squared will give you 3x 4. So this will be 3x 4 minus 3x squared plus 3x squared. So it says dead mice smell bad. So we are dividing. Now we did the multiplication by 3x squared. Smell bad, that means subtract. So we will subtract this whole entire equation. So what I will do, I will write the whole entire equation first. And then I will subtract it. So when you subtract it, 3x4 will become negative 3x4. Let me rewrite it again. Because there was no x cubed expression in the numerator. And if any expression is missing, right? For example, after x4, it is directly going to x squared. I need to plug in the x cubed expression. How? By writing 0x cubed. Now after this, I can start subtracting it. So we can cross off a few things. And then we will rewrite what is left over. So the leftover will be 3x cubed, because 0 and minus minus will become positive. So negative 5x squared, and then bring down 5x. Now we will do that drill again. Now we need to find a way to get rid of 3x cubed. So to get rid of 3x cubed, what we can do, we can multiply the denominator or the divisor by 3x. So that will give you 3x times x squared minus x plus 1, which is 3x cubed minus 3x squared plus 3x. So we will rewrite this entire expression and subtract it. So I prefer to write the expression in the parentheses and put the subtraction sign outside so that I know I need to distribute the subtraction sign. So this will cross off the 3x cubed, and whatever is left over, be careful with the subtraction because the minus sign will be distributed, right? So this will give you 2x squared plus 2x. At this point, if you want, you can write it in the quotient, remainder, and divisor format, or you can reduce this further. So let's understand it how we can reduce it further. So let's first write down in the quotient, remainder, and the divisor format. So we can say 3x squared plus 3x plus negative 2x squared plus 2x, everything divided by x squared minus x plus 1. Because sometimes the textbook will end the case right here, even though we can reduce it further. So the first expression, 3x squared plus 3x, is called the quotient. The leftover part, that is the negative 2x squared plus x 2x, is called the remainder, and whatever is in the denominator is called divisor. Sometimes they also call this as QRD. Q stands for quotient, R stands for remainder, and D stands for divisor. Now let's try to reduce it further. So we got negative 2x squared plus 2x divided by x squared minus x plus 1. So we will do the same thing again, the long division again, because I prefer to reduce it till the point I can. So if I multiply the denominator by negative 2, I will be able to cancel out negative 2x squared and 2x as well, and we will be left with only negative 2. So this is the complete division will be something like this. Negative and negative, it will be plus 2. So the final result or final answer should be 3x squared plus 3x minus 2. Minus 2, that means the quotient for this particular problem, and the remainder is 2. 2 divided by x squared minus x plus 1. This will be the complete long division process, right? Now, I want you to try 2 questions, and remember, don't leave the answer with incomplete remainder. Try to divide as much as possible. So these are the 2 problems, and try the same process. Go slow, and if you have color pen, try to use color pen so that you know distinctively what you are subtracting and when you are subtracting. So it will make a little bit more easier for you to navigate for the first few tries. Now the second thing in this polynomial division is called something called synthetic division. Synthetic division is something that is not known till algebra 2. So understand it a little bit carefully. Synthetic division is quite easy and it is fun to do. For the simplicity's sake, in x-rated algebra 2 or in pre-calculus, we are looking for synthetic division for dividing by a linear function. That means x minus k. But there are other tricks through which you can use a synthetic division even with the quadratic. That means dividing by a quadratic. But for the basic understanding, we are only dividing by a linear function. So k is any real number, and there is a process that we need to follow for dividing the synthetic division. So this is the whole entire process. So we have expression ax cubed plus bx squared plus cx plus d, and that needs to be divided by a linear function. So k will stand outside, that is my divisor, and we will write all the coefficient. So we are writing all the coefficient, and then we will follow the steps. Here's the thing, the vertical pattern, they add terms. We are not subtracting in this case, even though it is a division, we are not subtracting, we are adding. The vertically will be adding and the diagonally will be multiplied. How it will work? Let's understand with this example. So I know from x minus 2 that k will be 2, and we will write all the coefficients first. let's write the coefficient. And as you can see, the way synthetic divisions layout is, it represents L shape, right? So what we will do, we will bring first coefficient down, which is 6, and after that we will do diagonal multiplication. So 2 times 6. So 2 times 6 or 6 times 2 will give you a 12. And remember, we do vertical addition. There is no subtraction in synthetic division. In long division, we do subtraction. In synthetic, we do addition. Now, negative 19 plus 12 will give you negative 7. Now, this is my new number. So, new number times k. What is k? K is 2. So, negative 7 times 2, that will give you negative 14. And then we will do vertical addition again. So 16 minus negative 14 is 2. Now we have new number times k. So 2 times 2, which is 4, and that will give you a 0. So once you get the remainder as 0, that's what we are looking for, right? Now, what will happen? What we will do with 6, negative 7, and 2. Here's the thing. With the expression, we started with cubed, right? So we will descend. Instead of writing cube again, we will write squared. So this will be, the leftover will be 6x squared minus 7x plus 2. But can I reduce it further? Yes, it is a quadratic, and we can factor the quadratic. So if you factor the quadratic, you will get 3x minus 2 times 2x minus 1, right? Now we can write all the factors down. So remember, even quotient is also a factor, and divisor is a factor. So everything will be included. So zeros are, we have the divisor, which is x minus 2, and the quotient, which we factored it again. So x minus 2 times 3x minus 2 times 2x minus 1. And with this, if the question asks for to write the values of x, we can say what are the values of x. So divisor and factors combined together, they are the zeros of the problem. So x will be 2, 2/3, and 1/2. So when you will try synthetic division on your own with your own hand, it might seem a little bit messy, but after 1 or 2 questions, it is quite smooth and you will have fun with synthetic division. But remember, quotient is also a factor. I tried one problem for you. I want you to try one problem on your own and see how the synthetic division will go. So here is the problem I really want you to try. So divide by synthetic division. And the expression is this. Again, we are just talking about dividing with the linear. How to use synthetic division for the quadratic, I will explain in some other video. Okay, now with that, the another key component of this chapter is called the remainder and the factor theorem. So these are, they will be dealt in 2 different ways because there is a theorem that are totally different. So remainder, for the remainder, what we are looking for, we are saying if the polynomial f of x divided by a linear function, that means x minus k, then the remainder is nothing but f of k. That means if I plot the value of k in the function, that is the remainder. And for this, we use synthetic division. Right. Then for the factor theorem, it says polynomial f of x has a factor which is a linear function x minus k if and only if, that is if and only if f of k is equal to 0. So if you remember when we did the synthetic division, the last term, it generated the remainder as 0. This is what they are talking about. So if f of k generates the last term as 0, then only x minus k will be the factor of the polynomial function. So let's try a few questions, one question for each, and understand it. So the question might say, use the remainder theorem. They will specify it. So use the remainder theorem to evaluate f of x when x is equal to -2. Now, what do you mean by x is equal to -2? I can also write x is equal to -2 as x plus 2, right? That is nothing but the linear. So that is k is -2 in this case. So I know what is k, and we can write the synthetic division by taking the coefficient of the f of x function. So what's my first step? Bring 3 down. Bring first term down, then keep on multiplying the numbers and do vertical addition. Now, when I do the vertical addition for the last number, I'm not getting a 0 right now. I got -9. So -9 is the remainder. So R is equal to f of k as per the remainder theorem. So let's plug f -2 and see what the function will generate. So if I plug -2 in the function, I will get -9. So my coordinate is -2, -9. This is what this remainder theorem talks about. And can I check this? Yes, we can check by plugging it into f -2. That's what I just wrote. But I'm just showing it to you how I got -9. I plugged the value of x as -2 in the whole entire original function. And when you solve this whole entire function, you will get -9. So this is the gist of the remainder function, right? So the last term after vertical addition, that is the remainder, and that remainder should be the same if you plug the value of k in the original function. Now let's take another example for the factor theorem. So show that x minus 2 and x plus 3. So they have given you two factors in this case. And they want you to prove that these two factors are the factors of the given function. And also, you need to find if there are any other factors of the function as well. And again, even for the factor theorem, we are using synthetic division. But we have to use the synthetic division twice because we are trying to find out whether both the linear functions, they are the factors or not. Now, we will do the same thing again. So we will use a synthetic division first for x minus 2. So x minus 2 implies that k is 2. So let's write down all the coefficients of the function. And k will stand outside in the L format. So the first step is to bring first coefficient down, do diagonal multiplication and vertical addition. So keep this thing in mind for synthetic division, diagonal multiplication, vertical addition. If I keep on following this, diagonal multiplication and vertical addition, I am getting remainder as 0. So because the remainder is 0 for the last term, that means x minus 2 is a factor of the given function. So first thing is proved. Now I need to prove whether x plus 3 is also the function. For proving for the second function, what we will do, we will take the leftover of the first synthetic division. We are not taking the original one. So whatever the leftover coefficients are, 2, 11, 18, and 9, we will take these as the coefficients, and then we will use negative 3 as k. So in the L format again, remember diagonal multiplication, vertical addition. And if diagonal multiplication and vertical addition gives you 0 for the last term, that implies that is a factor. Here you go. We got 0 again. So that means this is also the factor. Now what is left? We left with 2, 5, and 3. But remember, we did the synthetic division twice and we started the function with the highest power of 4. So after 2 synthetic division, what will be the highest power left? It will be x squared. So your function, leftover function, will be 2x squared plus 5x plus 3. Now, here's the thing. This is quadratic. Can you factor the quadratic? Yes, we can factor the quadratic. Let's factor it. So if you factor the quadratic, now you know how to factor the quadratic. We have explained this in the previous video. We have discussed it. So we will get 2x plus 3 and x plus 1. So these are the additional factors of the function. So the complete factorization will be f of x is equal to the two factors that they have already given, that we proved that they are the factors, and the factors that we got after factoring the quadratic, which is 2x plus 3 times x plus 1. Do not leave the expression as 2x squared plus 5x plus 3 as one of the factors, because it is not in the factored form. You need to factor it. This is called complete factorization. So the whole entire process. So remember remainder theorem and the factored theorem. After this, it is a time for you to try a few questions out. So this is the question. Factor of f of x is equal to x cubed minus 19x minus 30. And then you need to find the remaining factors of f of x. But if you look at the function closely, something is missing from this function. So the hint is, because x squared is missing, after x cubed we are jumping directly to x. Use x squared term as well. And you know how to use x squared term? We have done it in the first example of this video. So what you can do, you can add 0x squared before you start the synthetic division, right? So this is how you will do the polynomial division. Bye-bye.